Hi, I'm with John Gallagher from Pulse Electronics, and John is going to talk to us a little bit about some of the things that design engineers and circuit designers need to know when they're working with a company that makes transformers and inductors. So John, you work with these guys. Do you see any common problems or common difficulties that arise when they need a transformer or an inductor?
Sure. A lot of our customers look at our transformers and think it's kind of like an ideal transformer. So there's just certain turns in this primary, certain turns in the secondary, and you just get this perfect answer. Magnetics in reality don't work that way. So there's a lot of gotchas. There's core losses, AC losses, fringing effects, all sorts of things that affect your efficiency, which affect your thermals. So when we first start talking to people, they don't tend to give us all the information that we require. And if they don't give us all the information that we require to design a good transformer, then they get a product that won't work as well. So if they're willing to work with us, answer our questions, give us the answers up front, we can get a much more efficient and better performing product. Some of the key things is customers don't understand things like high frequency losses. In high frequency losses, you get almost counterintuitive effects where you get higher and higher losses even though you have a bigger and bigger part. And people get confused by that and sort of don't believe it. It seems a little bit like mad science, but it's very, very real. So again, we need to know a lot of things like that to get a good design.
What kind of frequency ranges are you talking about when that?
It's a good question. So we've got a wide range of products. So we go from, let's say 50 kilohertz in some of our very large magnetics, all the way up to about 3 or 4 megahertz on some of our smaller stuff. So definitely a trend to higher frequencies. But if you're doing a 11 kilowatt converter, you're not going to be at a megahertz. You're going to be at 100 kilohertz. But when we're doing some of our higher stuff that we do for data centers, data center computing, those are switching at 4 or 5 megahertz. And that's kind of as far as the industry's gone right now in terms of switching speeds.
What about magnetic materials? Are you seeing any problems that arise when you change materials?
Absolutely. There's a lot of different materials out there. A lot of the materials are advertised at sort of that they can do a certain function, but then when you go to use them in that way, you find out sort of little gotchas, little problems that maybe are different. As you take a core shape and change it, make it smaller, change the construction, it also adds to the losses. And there's no way to anticipate that. So you have to do a lot of testing. So we have a lot of in-house test capabilities to actually measure our components in the real world situations, put the proper waveforms through. We're seeing, as the frequencies get higher, a lot of known phenomena, but things that we haven't had to deal with. So sort of things that you learn about, but haven't had to actually worry about. So fringing losses within the transformer, proximity effects that maybe are not as important at low frequency, but as you get those frequencies up, become very critical.
We've got a few examples of things you've done behind us, so why don't we take a look at a couple of those?
Sure. So what I'm showing here are two components. On the right side is a 3.3 kilowatt LLC transformer. LLC is just a type of topology used in a power supply. And you can see here we've got just the transformer, primary and secondary winding, does 3.3 kilowatts for onboard charging in vehicles. On the left side is a similar part where we've taken the transformer and integrated into it the resonant inductor. This allows us to ship one component, but it does two different functions. That saves footprint for the customer, helps with thermals, and also saves money. So what we have here is a power inductor that's used in server applications to power memory processors. And what we've done is taken 3 inductors and integrated them into one structure. Usually you would buy 3 separate parts, and this way you can save board space, you can save money, and it also helps reduce the losses and therefore increases the power supply efficiency.
So John, where would people go to get more information about you guys?
Well, we have a very good website, pulseelectronics.com. And on that website, you can search for our products by the application conditions that you have. They'll bring you to our inductors or our transformers that fit that application. Samples are available online. They ship within 2 days. It's all in stock. So that's a very clean process. Also a lot of white papers and industry paper links.
Well, thanks for that, John. Who knew that transformers were that complicated?
It's an exciting field. Thank you.
Thank you.